Question 16 gives us a shaded area between various lines. Now, normally we have to create that shaded area, but this time we have to define it by finding out what the lines are. This question is slightly vague as to the area that we want is bounded by 4 straight lines. It doesn't quite make it clear. Is the line included or is it not? In other words, are these the barriers that it doesn't quite reach or not? I'm going to assume that the shaded area reaches the line. So the effects of line 1, first of all, the y values of our shaded area must be less than or equal to 6. So without any of the other lines involved, this would be this whole area below y equals 6. Line 2 puts a new restriction on, and this is the line x is equal to -3. So our new restriction is that x must be greater than or equal to -3. The best way to quickly work out the gradient of this line is to set up a right-angled triangle like that. The gradient is certainly negative, and we fall 2 as we go along 4. So the gradient will be -1/2. Our y values must be greater than or equal to -1/2, which is the gradient, x, and the intercept of line 3 is +1. Now line 4. We're effectively above the line. Even though it looks like we're hugely to the left, we're going to be quoting x's, but we are actually above the line. It's a positive gradient. Rise over run, we rise by 1, 2, 3, 4, 5, 6 as we go along 1, 2. So it's got a gradient of 3. So y must be greater than 3x. And what's its intercept? It's 6 plus 6, or greater than or equal to. And if you join all those 4 inequalities together, you will get the shaded area. And that's your answer.